What's good, everyone? In today's video, we'll do a bit of a introductory type kind of style video. We won't have any example kind of hands-on. What I wanted to talk about was training machine learning models and how you specifically can do that on Amazon SageMaker, and go through kind of the different options that exist. Because while SageMaker is a very, very powerful service, there's also a whole suite of options kind of within every step of the ML lifecycle. So it can be a little kind of overwhelming if you're new to the service, but once you get a general understanding of the ecosystem, what each option stands for, and what each option applies for in terms of use cases, then you'll get a better understanding depending on your ML problem that you might be trying to solve. What's the right feature that I could be using? So the two high-level options that we'll talk about first are training jobs and SageMaker Hyperpod. And then there's also a tab within the documentation, right, that I wanted to clarify here, and also explain maybe when you can use them. That's model customization. This is at the moment specific to the Amazon Nova model family, and we'll talk specifically about how you can inject these different training recipes that will let you customize the Amazon Nova model family. So Nova is Amazon's set of proprietary models, for those of you that are curious, and essentially there's training options within that as well that we'll cover. But first, let's get to training ML models. I know I have talked mostly about inference on this channel, but for most niche use cases, you need some sort of customization, and you need to be able to train your ML model on your own data to kind of solve the problem that you might be tackling, right? And with training ML models, we've seen that we often work sometimes in SageMaker notebook instances, or kind of like SageMaker Studio. And this is very similar to how, as a data scientist, right? At least when I was first a data scientist, when I was learning, I would kind of be in a notebook and I'd just kick off the training within that notebook itself. What's neat is these give different compute options, such as like CPU or GPU basically, that you can also train on, and you can technically run a notebook directly here. But the same pitfall exists when we talk about production grade ML workflows, where you can't really just have your scripts kind of lying standalone in a notebook, because normally within the MLOps workflow, right, we have all these different steps linked together. And if you just have a standalone notebook that's just doing training, kind of isolated, it's very hard to interface it with some sort of data engineering, with some sort of model inference or deployment, or any kind of model cataloging that you might be doing as MLOps best practices. So while there is compute available, and while I do encourage you to maybe like prototype or kind of POC on a classic notebook, or a studio notebook with the compute that you think is needed for your model or data, it's not very scalable when you're talking about an overarching ML workflow. So that's problem number one. And then problem number two also is, right, when we scale up our training to kind of distributed training, which is especially common for LLMs, where you have to shard the model or the data as well across multiple nodes or instances. So we call this model and data parallelism. You honestly need more than just one instance, and with these classic notebook instances, right, you just have a single instance behind it. And when it comes to kind of sharding your model or kind of splitting your data across multiple instances, it's not scalable in that sense. So one, you can't adhere to MLOps best practices, I'd say. And then number two, you also can't really conduct training at a large scale when you have a large model or a large set of data where it will require multiple nodes or multiple instances for training, right? And that's what led to the evolution of a few different options. And then option one is the training job itself. This is the SageMaker training job. And what's provided here, right, at the manager layer is a training container. So just like inference, where you have containers that provide kind of that runtime environment to be able to execute the code that for your specific model training, there's managed training containers that are provided for example, Hugging Face models, PyTorch models, TensorFlow models, whatever framework you're kind of working in, basically. And what this training job is, via that managed container, it will provide different frameworks or versions that you might have used to kind of basically kind of train your model. So if you use Hugging Face, I don't have the versions memorized, but let's say Transformers version 2.x, and then Torch version 4.y, whatever it is, right? This might be completely wrong. I don't have the dependencies memorized here. But if you have this, right, you can basically specify these are the framework versions that I was using, pull down the appropriate container that will provide the runtime environment to execute my training code. And what this training job then does is it also allows for you to provide a training script. And we'll have a specific video on how you can configure a SageMaker training job for Hugging Face models. I figure that's probably the most popular use case, at least now with all this LLM stuff that's happening here. But with that training script, you can basically have your model training code. So you can think of this as kind of defining, right, your different hyperparameters you might be working with, like epochs, learning rate, whatever else it is, right? Um, Essentially, you can define these, kind of inject them almost into a command line script. So we use the Python args library, argparse, whatever it's called. I don't know the formal name for it. And you can essentially inject these different hyperparameters, and then you can have your custom training code within it. So whether it's you're using the transformers trainer class, whether you're using vanilla PyTorch code or TensorFlow code, whatever code you might have standalone in that notebook, you could provide in this training script. And there's the SageMaker kind of provided directories for which you can push artifacts to. So this path might not be fully accurate here, but for example, if you have kind of output logs that you might want to capture or emit, that's the path the container is expecting. You might also have something like opt.ml model data, and this is essentially where your model artifacts are pushed or things of that sort, right? So there's this training script. This is where your custom code that you'd be building as a data scientist or ML engineer that you can provide directly to the training job. And then the other thing that you can also do, right, is, or the other thing that also comes with SageMaker training jobs is you can specify the hardware. So whereas with classic notebooks or kind of studio-based instances, right, you only have a single instance that you're working with behind that environment, you can specify multiple instances, and this can once again be CPU slash GPU. And excuse me if my voice is a little hollow, still a little under the weather. But here we can specify multiple instances. You can specify kind of distributed data strategy. So you might be using something like PyTorch, data parallel, something of that sort. SageMaker even has its own built-in kind of model parallelism library that you can work with. Any kind of distributed data strategy that you're working with, you can bring and you can specify because you can work across multiple nodes. And this is very, very powerful, right? When you have a use case where you need model parallelism and data parallelism, and you can imagine when you have large sets of data or even larger models, especially in this LLM-based world, you need to have that flexibility to have that distributed data and model parallelism that we're talking about right there. I'm definitely butchering how I'm saying parallel there, but that's the general idea with a SageMaker training job where you have this runtime environment configured and managed for you. You can bring your data science script for actually training the model and working with the model. And then you can also specify a kind of distributed data strategy where you will define your model parallelism or data parallelism that you want to be working with, depending on the library or framework you're using there. So that's a SageMaker training job, which is great. But in the case that there's even more kind of hyperscale use cases that you're working with, no pun intended there, you will have SageMaker Hyperpod, which is cluster-based environment. So a lot of people come from kind of the EKS world where you have multiple different nodes or instances, and you can kind of split your data and model across that, right? And that's completely fine. You can go that route too. But it's also nice kind of having managed clusters basically, where a lot of the maintenance of these different nodes and the node to node communication is kind of taken care of for you. And where SageMaker Hyperpod is popular is it offers EKS and Slurm as basically controllers. So for how you want to kind of execute your training strategy, or there's also inference on Hyperpod now. And what you can do is similar to like EKS, you can provide a YAML file, and these are going to be managed operators for you basically that execute your training strategy here essentially. So with Hyperpod, what comes is you can almost think of it as a managed cluster-based environment where you can still inject your training recipes and scripts. But here, unlike SageMaker training jobs, where you can still provide multiple instances, but it's not a cluster, right, that you're working with here, and you don't have this controller via EKS or Slurm. If you're coming from one of these worlds, basically, it's very easy to map over to Hyperpod, where you can define this training strategy through this operator. And there's a lot of kind of managed features that comes in basically with checkpointing, and then there's also like different stuff basically that also comes into play also with kind of like node health, instance failure, anything of that sort. There's that managed layer basically that SageMaker kind of provides on it. Once again, if you want to execute on just EKS as well, that's completely fine. There's just this managed angle to essentially what's happening here. So with Hyperpod, right, and this is kind of leading into our next spot, there's also pre-made recipes that are provided by SageMaker as well. So for different popular LLMs, you can imagine Hyperpod's mostly used for customizing foundation models from ground up because you need a cluster of instances to be able to kind of split this model over and this data over. So for Mistral, Llama, and then also Amazon Nova, which we'll talk about. There's a lot of pre-configured recipes in terms of the hardware that you'll need for these clusters, and then also the training hyperparameters for different strategies such as QLoRa and PEFT, and then also kind of different kind of reinforcement learning algorithms that you might be working with. There's a bunch of recipes that are pre-made. I'll attach them down below by the science teams at Amazon, where you can basically configure this as a recipe, which defines your kind of training workload. So these are the controllers that are available via EKS and Slurm, and these recipes are kind of the data science meat or knowledge that you're providing in terms of how you should be utilizing your hardware to conduct the training on the cluster. And that leads to my point to model customization. This is another tab. You might see the documentation, and we'll briefly jump over there. With model customization, you can essentially provide these recipes not just to SageMaker Hyperpod, but even training jobs. And keep in mind, different algorithms might be supported for different options here. But with Amazon Nova, for example, there's a list of pre-configured recipes that exist for both conducting on training jobs and Hyperpod. So if you see kind of that recipes tab or structure within the documentation itself, these recipes are basically once again defining the data science knowledge that exists behind conducting this on either of these training options. And you can see this here. I'll link all the docs down below. You'll see for model training, right, you'll have different use cases here where you can use kind of built-in algorithms that also exist, and you don't need to worry about that. But here you can leverage SageMaker training jobs basically by bringing your own code. And it's called script mode when you provide your own script. But with SageMaker training jobs, you have that managed container or runtime environment to execute training. And then you also have the ability to kind of bring your own container like we talked about with inference, but depending on your use case, right? So for ML training workloads at scale, that might require multiple instances, but you still want that managed environment and to be able to bring your own code. And then also something where you might have kind of distributed mode. And then you have SageMaker Hyperpod here, where you have these kind of cluster-based instances where you can, really the main use case you can think of here is when you have LLMs that you might be training from scratch. So for example, like something like Perplexity, just using that as an example, if they have a foundation model they want to train from scratch, this would be kind of like an option there in terms of what they could be leveraging. So anytime you're kind of a model provider and you need to customize your model from ground up, using a cluster-based tool like Hyperpod will be very, very effective essentially. And you'll see the different controllers basically, or Slurm and EKS are available, and this is what will be your orchestration tools essentially. So if you come from the EKS world, right, you'll know how in those YAML files you can kind of configure the behavior that you want to be conducted here. And then the other thing that you'll also see is there is this model customization. This is referring to Amazon Nova at the moment, where you can provide these pre-configured recipes and do different types of training, such as SFT-based or, like I said, different reinforcement learning kind of techniques. And these recipes exist within this kind of Git link right here. And you can take a look at it for SageMaker Hyperpod recipes. And you can see for full-scale training for different kind of model families, what might exist and where do they exist for. Is there something for training jobs? Is there something also for Hyperpod, right? You can kind of come here, and this is basically a lot of that data science work and knowledge being taken care of for you. So if we take a look at Llama, for example, and we'll see, for example, implementing LoRa, this YAML file will basically provide the different hyperparameters that you can kind of tune. You can obviously play with these. These are not pre-configured, so if you're a data scientist coming from that world where you want to be able to play with these different options and parameters, you can go that route too. But essentially, these are pre-configured ones depending on tests that the science team has basically done already. But yeah, I'll link all this down below as always. And we will get hands-on. I'll showcase how you can train models through both training jobs and Hyperpod. Obviously, you're going to need the compute for it as well. So I'll showcase how you can increase your service quotas for what type of training you need to do. We'll get started with training jobs because that's a more simple use case to get started with at least. But yeah, that's mainly what I wanted to do today. If you have any questions, as always, please drop it below in the comments. Reach out to me directly on LinkedIn or Twitter or wherever it is you feel comfortable. And I'll do my best to get back to it. If you enjoyed the video, feel free to leave a like and subscribe. And like I said, there's a lot more coming in model customization and training that we'll cover both on SageMaker and off. So thank you, everyone, and hope you have a good day.